Okay, so for this video, we're going to talk about the intermediate value theorem and turning points. So for the intermediate value theorem, what this basically says is if you have a polynomial and you have two answer values, so two y values that have opposite signs, so one of them is positive and one of them is negative, then somewhere between their partnered x values, you have a spot where the answer is 0. Okay, so I'm going to show you a picture of what this looks like. Okay, so here is the concept. You've got, we're just going to draw an x-axis here. Okay, I'll go ahead and put a y-axis in here as well. So here you've got some point A, and this is at some f of A, so it's positive. And then here I have B, and it has a negative answer. Okay, so f of B, excuse me, let me draw that better. F of B, so I have some point down here. Now, what this says is somewhere between A and B, I have to cross over the x-axis, or I have to equal 0. Because if you're going to tell me that these are connected in a smooth, so not sharp pointing, continuous or connected graph, there's no way you can connect this point to this point without crossing over this spot. Okay, and it happens at least once. Now, bare minimum, it happens one time. However, it could happen multiple times. Okay, there's not a specification. It just says it happens at least one time when this happens. Okay, now I started going from positive to negative. The same option still holds true, and we'll show these. We'll even put them both on the same side. Here is A, here is B, here's f of A down here, here's f of B up here. Again, if you're going to play connect these dots, you've got to cross over the x-axis somewhere between here. Now, the reason this is helpful is sometimes I may not be able to factor, or I may not be able to solve the equation as simply. But if I can get two spots where one is positive and one is negative, then I can utilize, okay, the fact that somewhere in between there, they have to cross over the x-axis, which means I can at least get a ballpark. Now, the idea here is we do want to try and have A and B be somewhat close together. So let's take a look at an example. Okay, and we'll see how this works through. So it says, show that the polynomial function f of x equals 3x cubed minus 10x plus 9 has a real 0 between -3 and -2. Okay, so what that means that we're going to do, okay, is we are just going to plug in. And the only thing we've got to show is that one of these two numbers, x values, gives us a negative answer, and the other one gives us a positive answer. So we're going to start with -3. So we're going to plug in -3 in for x, and we're going to see what we get. So -3 cubed is going to be -3 times -3 is 9 times -3 is -27. So -27 times 3 is -81. -10 times -3 is +30. And I have plus 9. So -81 plus 30 is -51 plus 9. That's going to be -42 when we get that. So now I'm going to plug in -2. So I'm going to do 3 times -2 cubed minus 10 times -2 plus 9. So -2 times -2 is +4 times -2 is -8 times 3 is going to be -24. -10 times -2 is +20 plus 9. So I've got -24 plus 20 is -4 plus 9. -4 plus 9 is 5. I have one answer that's negative, one answer that's positive. Now, graph-wise, 1, 2, 3. Way down here is going to be -42. Up here is going to be 5. That means somewhere between -3 and -2, I have to go over the x-axis. Now, I don't know where it is in between those, but I do know it's in there at least once, okay? So now, if we take a look in our PowerPoint, okay, we've got, they show this a little bit better. So here are the same answers that we got. F of -3 is -42. F of -2 is 5. So I've indicated those 2 points here. Since the sign changes between, we know that there is. And notice here, here's -3, here's -2, and they're showing there's where it crosses over. It is a little bit closer to -2 than it is to -3, which is kind of expected because the -3 answer is so far down at -42, but at -2 we're at 5. Okay. Now, the other thing that we need to discuss is what's called turning points. Okay. Now, turning points are hilltops or valley bottoms. Okay. So what there's a rule that states if your highest power is n, then you can have up to at most n minus 1. So if n is 5, then I can have 1 less, which is 4. So I can have 4 hilltops or valley bottoms. Now, touch and turns count as those, okay? Now then, it also says at most. It doesn't mean that I have to use them all. It just says that's how many there could be. Now, generally when I'm doing graphs, I always try to do the simplest things because it's always easier to embellish and add more humpy, bumpy, lumpy things in than it is to try and take them out. So oftentimes I will do very simple connected graphs and use the fewest amount of hilltops and valley bottoms as possible, and then know that they could have more. And most of the time turning points are used to eliminate graph options if we're looking at multiple choice stuff.